Welcome everyone to today's Explainer. Okay, let's just dive right into this because we have a genuinely thrilling investigation ahead of us today. We are going to track down an invisible, totally silent saboteur. It's a phenomenon that literally permeates our entire universe, constantly showering down around us, and yet, most of us go through our entire lives completely oblivious to it. But as we'll see, this unseen force has the power to dramatically alter our digital world. Consider this bizarre question for a second. What connects a plunging airplane, an impossible video game glitch, and a rigged election? I mean, it sounds exactly like the setup to a science fiction thriller, doesn't it? But actually, this is not fiction. These are real events, and teasing out the connection between them reveals that the universe itself is, in many ways, fundamentally hostile to the technology we rely on every single day.
Let's move to our first crime scene. Section 1. The 4,096 vote mystery. Belgium, May 18, 2003. We're going to see how an impossible surge in votes completely baffled computer experts. So, that night in Belgium, a relatively unknown candidate named Maria Vindevogel received a massive, mathematically impossible surge of votes. Computer experts combed through every single line of code, they tested the hardware, and nothing. No bugs. Perfect working order. The smoking gun was finally discovered during a manual recount, because luckily the voting system had a physical backup using magnetic cards, so officials were able to recount every single vote by hand. And what they found was that Maria's initial computer tally had been inflated by exactly 4,096 votes. Not 4,000, not 4,100, exactly 4,096. And for computer scientists, well, that specific number was a massive clue. The reason this specific number is so incredibly important comes down to binary math. As you know, computers think in binary, just strings of zeros and ones, with each position representing a power of 2. Well, the number 4,096 is exactly 2 to the power of 12, and that corresponds to the 13th bit in a binary sequence. So for Maria to magically gain 4,096 votes, only one physical thing needed to happen inside that machine. A single microscopic transistor, the one representing that 13th bit, spontaneously flipped from a 0 to a 1. But here's the catch. Computers are designed specifically so that bits don't just flip on their own. So, what pushed it? That brings us to Section 2, tracking the invisible culprit. From Intel to the Eiffel Tower. To find our invisible saboteur, investigators actually had to look way back at computer history. When the Belgian investigators really dug in, they found that the chip giant Intel had dealt with something incredibly similar back in 1978. Their memory chips were seeing ones spontaneously flip to zeros. Why? Because the ceramic packaging encasing the microchips had trace amounts of radioactive uranium in it, emitting alpha particles straight into the silicon. This whole phenomenon is defined as a single event upset, or SEU. We call it a soft error because, well, the hardware isn't actually broken or permanently damaged. An energetic particle simply hits the chip with just enough charge to alter the electron well, flipping the bit. You can just erase it and rewrite it. Now, chip makers figured this out and stopped using radioactive packaging by the late 70s. So the absolute crucial point here is that the Belgian voting machine in 2003 did not have radioactive packaging. The particle that flipped Maria's vote absolutely had to come from outside the computer.
To figure out where it came from, we have to look back at this timeline. In the early 1900s, scientists basically thought background radiation just came from the Earth's rocks. But in 1912, an Austrian physicist named Victor Hess took radiation sensors up in a hydrogen balloon. At 1,100 meters, radiation didn't really change much. But as he climbed to an astounding 5,200 meters, the radiation levels didn't drop. They multiplied. It was several times greater than down on the ground. He even did a balloon flight during a solar eclipse, and the radiation remained super high, proving these particles weren't primarily coming from our sun. Without realizing it at first, he had discovered cosmic rays.
Which perfectly transitions us to Section 3, a shower from space, the cosmic cascade. Today, we know for a fact that these invisible saboteurs originate from the absolute most violent events in the universe.
So what are they? These cosmic rays are high-energy subatomic particles, mostly protons and helium nuclei, literally shot out of exploding stars, supernovas, and supermassive black holes. They wind their way through the magnetic fields of deep space for billions of years. To really grasp the sheer kinetic power of these particles, you got to consider what scientists dubbed the OMG particle back in 1991. It was a single subatomic particle. We're talking smaller than an atom here, and it packed 51 joules of energy. To put that into perspective, that is the physical equivalent of a baseball flying at 100 kilometers per hour, all contained within a single invisible proton. That is mind-bending.
And fortunately for us, primary cosmic rays like that OMG particle don't usually hit the ground intact. Instead, they trigger what's called a physics cascade. Let's break it down. Step 1. The primary ray strikes our atmosphere about 25 kilometers up. Step 2. It violently shatters air molecules, creating secondary particles like pions. Step 3. These decay into an absolute shower of neutrons, muons, and electrons. And finally, Step 4. One of those secondary particles streaming down to Earth crashes right into a silicon transistor. And that, right there, is exactly what investigators suspect hit the Belgian voting computer, flipping that 13th bit and giving Maria 4,096 extra votes.
Let's move to our next section, glitches in the matrix, when bits flip in real life. Now, you might be sitting there thinking this was just a one-off freak accident, but these invisible strikes are happening all around us, literally all the time, causing bizarre consequences in our everyday tech. Get this, cosmic rays even impact the world of competitive gaming. Back in 2013, a speedrunner who goes by the name Dota_Teabag was playing Super Mario 64. Out of nowhere, Mario inexplicably warped straight up to a higher platform, saving precious seconds on the run. For years, the speedrunning community tried to replicate this glitch. They even offered a $1,000 bounty, but literally nobody could do it with a controller. The best and only working explanation is that a cosmic ray hit the Nintendo console, flipping a single bit in the exact byte that controlled Mario's height coordinate. So yeah, a particle from a distant black hole literally helped a gamer cheat at Mario. You can't make this stuff up.
And the glitches go way beyond video games. Have you ever gotten an unexplained blue screen of death on your personal computer? Well, that might have just been a cosmic neutron crashing your system's process. In fact, back in 1996, IBM estimated that you'd see 1 bit flip per month for every 256 megabytes of RAM. The risk of these soft errors is taken so incredibly seriously that when Toyota had to recall millions of vehicles in 2019 for unintended acceleration, NASA was brought in specifically to investigate if cosmic rays were flipping bits in the car's electronic controls. Now, NASA eventually disproved it for that specific case, blaming sticky pedals and floor mats instead, but the mere fact that they investigated it shows just how real this threat is.
Section 5. High-altitude hazards. Danger in the skies. See, ground-level bit flips are rare annoyances, sure, but the danger scales exponentially the higher you go into the atmosphere.
Remember Victor Hess and his balloon? At higher elevations, the atmosphere is simply thinner, meaning we have way less protection. The Los Alamos National Lab supercomputers, which sit at about 2,200 meters above sea level, suffer constant, neutron-induced crashes purely because of their altitude. And just look at what happens when you climb to cruising altitude in a passenger plane. These Geiger counter readings clearly show that as you climb from 18,000 up to 33,000 feet, the radiation levels just soar. At cruising altitude, your chance of a single event upset, a cosmic bit flip, increases by 10 to 30 times. Now, if a bit flips in your laptop while you're casually watching a movie on a flight, no big deal. But what if it happens in the flight computer that is actively flying the plane?
On October 7, 2008, that exact nightmare scenario became a reality. A Qantas Airbus A330 was flying from Singapore to Perth. Suddenly, the plane violently pitched down, diving 200 meters in just 20 seconds. Passengers were subjected to negative G-forces, literally lifting them right out of their seats and throwing them into the ceiling. 119 people were injured before the pilots managed to regain control and make an emergency landing.
Let's break down the exact anatomy of this disaster. The plane's data computer, called the ADIRU, supplies flight data using 32-bit binary words. Investigators concluded that a high-energy atmospheric particle struck the CPU, flipping a bit right in the header of one of those words. This caused the computer to totally mislabel altitude data as angle of attack data. The plane's alarms went absolutely crazy, warning of an overspeed and a stall simultaneously, which, by the way, is physically impossible. Reacting to the false stall data, the automated flight computer violently forced the nose down. Because the plane was built back in 1992, before strict resilience requirements were mandated for these specific single event effects, it was totally vulnerable to the cosmos.
Which leads us to a critical question, and our final section, surviving cosmic bombardment, hardening our tech. How exactly do we protect our machines from the entire universe?
Well, for aerospace, the very first answer is extreme redundancy. The space shuttle, for example, had 4 computers running identical software. On just one 5-day mission, they caught and corrected 161 separate bit flips just by outvoting each other. But it gets crazier. Above the atmosphere, the bombardment is so intense that human beings can actually physically perceive it. Astronauts have reported closing their eyes in the dark and seeing spontaneous flashes of light. These are heavy cosmic particles shooting directly through the fluid of their eyeballs or striking their optic nerves. Your body is quite literally registering the radiation of distant exploding stars zipping right through your head.
This cosmic reality fundamentally shapes our space exploration. If you compare a snappy, modern laptop to NASA's Perseverance Mars rover, you'd probably think the rover is an absolute dinosaur. I mean, it runs on a clunky 20-year-old PowerPC processor with just 256 megabytes of RAM. Why? Because you can't just send a sleek, modern, unshielded processor all the way to Mars. If a cosmic ray hits a critical thruster control and flips a 1 to a 0, the mission is over. So NASA has to use older, physically larger circuitry that is specifically radiation hardened, making it 40 times more resilient than your ordinary computer. They literally blast these chips with particle beams in labs here on Earth just to make absolutely sure they won't give a blue screen of death in deep space, where a reboot is basically impossible.
Now, thankfully, we aren't entirely defenseless down here. Our own sun, while generating its own lower energy radiation, actually protects us. The solar wind creates this giant magnetic bubble called the heliosphere that surrounds our entire solar system. It deflects and slows down many of the most dangerous interstellar cosmic rays. But there's a catch. The sun operates on an 11-year activity cycle, meaning this cosmic shield fluctuates. When the sun is dormant, more interstellar particles rain down right onto Earth. The truth is, we are constantly swimming in a sea of ancient, high-energy particles. They have traveled for billions of years just to get here. And they don't just crash our computers. So ask yourself this: what if the next cosmic ray doesn't hit a microchip, but instead flips a bit in your DNA? Biologists actually theorize that throughout Earth's history, these very same cosmic rays have been driving the genetic mutations that fuel natural selection. We are shaped by the cosmos in more than one.
Whether it's an election official tracking down 4,096 ghost votes, a gamer analyzing a random glitch, or an aerospace engineer hardening a Mars rover, making sense of this invisible saboteur requires rigorous critical thinking. The universe is absolutely full of mysteries just waiting to be decoded. Problem solving is a perishable skill, folks, so keep it sharp. The next time your screen inexplicably glitches out, ask yourself, was it just a software bug, or were you just touched by a distant black hole? Thanks so much for joining me on this explainer, and I will see you next time.